for the whole integration, and then you can move on to other books. Okay, if you want to study the concept of integration at depth, just follow the basic books first, right? So I will discuss with you some basic functions which have some typical derivations. We will do the derivations as well, and we will write all the results on this right hand side. Okay, so I will start with the first basic function. So we will discuss 6 types. First one, type 1, is the integration dx upon x square minus a square. So we will learn how to do the integration of dx upon x square minus a square. Now this is nothing but, this can also be rewritten as 1 upon x square minus a square dx. Now we know that this denominator can be split into 2 factors. Now we know the factors. The factors are x minus a into x plus a. This is a pretty easy one. So we can write this integrand as x minus a multiplied by x plus a. So dx, right? Now you can see that the 2 factors here only differ by this plus and minus sign, right? So you can convert these into 2 partial fractions. How can we do that? I will show you the simpler way. What we can do is, we can write the numerator as the difference of these 2 factors. How can we do that? I can say this is x plus a minus x minus a divided by x minus a into x plus a. Now why am I writing this like this? Because I can cancel out these factors, x plus a with the denominator, similarly x minus a with the denominator later on. And you can see that in the numerator I am getting 2a, so I will divide this by 2a. So I'll explain again why I wrote this like this, because this became a numerical value which is equal to 2a. So I divided this by 2a and multiplied this by 2a and wrote it like this. And this can be written as 1 upon x minus a dx minus 1 upon x plus a dx. This is 1 upon 2a, right? Now if we do the integration of this, I will get 1 upon 2a. Now the integration of 1 upon x minus a dx, this is equal to log of x minus a, natural log of x minus a. So this is ln x minus a minus ln x plus a. And we know the properties of log. Log a, log minus log b. Log m minus log n is equal to log m by n. So this will become 1 upon 2a ln x minus a upon x plus a. So the first particular type we discussed. So the integration of dx upon x square minus a square, this is equal to ln x minus a upon x plus a, right? And in the front you will write 1 upon 2a. I will rewrite this again. This became a bit clumsy. So this will become 1 upon 2a ln x minus a upon x plus a, right? So this is a value. Now let's discuss the next type. Now you can see that we first covered x square minus a square. Now we will cover the type 2 where I am getting a square minus x square. So the type 2 here is a square minus x square. So in this case also we will do the same procedure. We will factorize this one. So I will get 1 upon a minus x into a plus x, right? And we will convert the numerator as the difference of these 2 factors, a plus x minus a minus x dx 1 upon 2a. Okay, so this will give you 1 upon 2a ln. If we do the integration, I will get ln. But first, let's go step by step. This is 1 upon a minus x dx minus integration 1 upon a plus x dx. Right? So this will give you 1 upon 2a. The integration of this, if you try to do, you will get a minus sign in the front and you will get a minus x, and also a minus sign here and a plus x. and this result I will get ln of a plus x upon ln of a minus x. Right? Now you know that whenever you do definite integration, you get a constant also, integration constant. So this will become ln a plus x upon a minus x. So the second type we discussed is dx upon a square minus x square is equal to 1 upon 2a ln a plus x upon a minus x plus c. So these are the two types, two basic types in which we just need to do the factorization and we can solve the questions. So let's do some questions. I will give you two similar questions. The first one is dx upon x square minus 16 and the second one is dx upon 16 minus x square. So tell me what is the answer of these two questions and we can match the answers. Okay, just do these questions. Hope you have done the questions. So in the first problem you can see that this is becoming x square minus a square. So you will apply the formula 1 upon 2. You know the value of a here is 4. Okay, this 16 is 4 square, right? So this will become 2 into 4 ln x minus 4 upon x plus 4 plus c. So this is 1 upon 8 ln x minus 4 upon x plus 4 plus c, and this will become 1 upon 8 ln 4 plus x upon 4 minus x plus c. So these are the final answers which I am getting after applying the simple tricks. Right? You can also go by the definition, the whole derivation, and also you can simply apply the formula too. Now let's see a question from the NCERT textbook. So from NCERT textbook, I am giving this question: dx upon 3x square plus 13x minus 10. So try to integrate this one. Now guys, see, we have to convert this denominator in such a form. Now you can see that since x square is positive over here, this is resembling the first type. Okay, if this x square was negative, this will resemble the second type. So that's how we find out which type this integrand will become, right? So this will be written as 1 upon 3 dx upon x square plus 13 upon 3 x minus 10 upon 3, right? So that's how we are going to write this. Now I am going to convert this term into a whole square. If you remember the method of completing whole square, you can simply do this. This will become dx upon x square plus 13 upon 3x plus 169 upon 36, right? 13 upon 6 whole square, which is 169 upon 36 minus 10 upon 3. Now this result will be equal to 1 upon 3 integration x plus 13 upon 6 whole square. And if you try to solve this one, now if I added this thing, I will also have to subtract this thing, right? That's how we complete the whole squares. So this will become 289 upon 36. Just try to solve this one. 289 upon 36. 289 upon 36 is nothing but 13 upon 6 whole square minus 17 upon 6 whole square, right? Now this has become the same type as this one. So the answer can be easily written as this is equal to 1 upon 3. 1 upon 3 integration will be removed and I will get ln of and 1 upon 2 into 17 by 6, right? So I will cancel these things, multiplied by ln of x minus a. So in case of x, I am getting 13 by 6 minus 17 by 6. Similarly, x plus 13 upon 6 plus 17 upon 6, right? So this is the final answer which I am getting, but I can also simplify the answer into a simpler form. Let's see how this answer can be converted into a simpler form. This will become 1 upon 17 ln 6x minus 4 upon 6x plus 30, right? This can be written like this. Now 1 upon 17 ln 3x minus 2 upon 3x plus 15. Now guys, see, 3x minus 2 upon 3x plus 15. How did we get this result? By cancelling out the 2 from the numerator and denominator, right? Now I can take a 3 common from the denominator, and I can write this as 1 upon 7 ln 3x minus 2 upon x plus 5 minus 1 upon 17 ln 3 plus c. And this whole, since this is a constant value, this whole can be written as some new constant which is equal to c dash. So I am going to write c only. So